Yes. So we are here in stage 1. Ethnobotany is one of the oldest scientific disciplines, dates back to centuries, because since human beings are created, we've been interacting with plants, with the environment. Now, what do? Us, we call ourselves scientists. We go to the village, we ask questions about the plant that our parents use, how they use the plant, which part of the plant they harvest, how do they prepare the concoction, and then we come back to the lab, to our office, take our laptop, and we write the report, the table, the organ, the name of the plant family, and the way it is used. And then that's it. We get our degree, we get our publication, and everybody's fine. This stage is extremely important, but the stage number 2, what is happening in stage number 2? We are not doing much in stage number 2. That's why you have this dash line. We are not doing much. So even until today, ethnobotany focus here. You get stuck in stage number 1, which is great. And then next, just to support what I just talked about, that ethnobotany is still in stage 1. This is a publication from one of my honor students. Honor student is 4 years degree in South Africa. And I don't know if you can see from far. So we have a book here with the different plants in the region. Let's say we take Kassina State, and we have the book of the flora of Kassina. And he went to the village showing the picture of plants to elderly people, asking if they know the plants, what do they use the plant for, which part of the plant they use, how do they prepare the concoction, etc., etc. And he came back, he wrote in his report, he got his honors degree. Even this year, I also published a paper in collaboration with some Asian colleagues on similar project where still in stage 1. We go to the market, we look at the plant that has sold for medicinal purpose. And even here, so it's not just about plant, it's also about animal. Also in that study I mentioned in the Western Himalayan region, where we went to the market and looked at the plant, the different animal, fish, and they use how they cook it and which medicinal, which disease is treated by the plant, etc. And we came back, we wrote the report with some fancy figures, and then we get it published. Right. Now, this practice has been criticized. It has been criticized by who? By ethnobotanists themselves. They're now saying we get stuck too much for far too long on this descriptive study. Now it becomes problematic because any scientific discipline is grounded on theories and hypotheses. If you take any discipline, at least in natural science, you take ecology or biogeography or any natural science discipline, and I'm sure the economy as well, you have theories that inform decision about the discipline. So to make a scientific discipline complete, the stage number 2 is important. And when you look at these two authors, this guy, Albert Quique, is from Brazil. He was one of the first who started criticizing this approach, the descriptive ethnobotany. And you have this guy, Alexiades, in 1996, who also contributed. What are those critics? The discipline does not have a unifying theory. The discipline remains descriptive for far too long. Can we predict what ethnobotanical knowledge, for example, in Kassina, can we predict what it may look like in 10 years? The answer is no, because we don't have theories on which ground can we make prediction. Can we predict species most likely to have medicinal properties? Of course we cannot, because we are in stage 1 where we only keep describing. And then the call is now that we have enough documented knowledge that can be used for theory development. And the strongest critics from these two guys is that the ethnobotany is a weak or pseudo-science. This is a very strong critic. And he received a huge, these two guys, they received a huge attack. If you are familiar with the literature, that it is insulting to say the discipline is weak. And what was their argument is that we don't have theory, we don't have a unifying theory that informs the discipline. Now, this guy here, Kowiyou, who is now an American, originally from Benin Republic, but now he's based at the University of Tennessee in the US, he decided in 2017, so 5 years ago, so he decided to respond to the critics by looking into the literature and look at different potential theories and hypotheses that we can use in ethnobotany. And it was him and his student. The work was published in Economic Botany in 2017. And in that work, they summarized 17 potential ethnobotanical theories with different questions and hypotheses that can be tested. Can you go to next? And 5 years later, which was this year, I joined the team, different team, but again led by him, where we proposed. The paper that was published 5 years ago in Economic Botany, it was pure theoretical. A lot of critics, but they did not propose how to solve the issue. It's going to criticize, but propose a solution and how to implement those solutions become more reliable. So that's what we did this year. I joined the team and we published this paper in Biological Review, Methodological Advances for Hypothesis Driven in Ethnobotany. And just to illustrate, I mean, in that paper, what did we do? We respond to the critics by proposing different techniques, statistical tools, the different variables that can be collected to test those hypotheses that were highlighted in the 2017 paper. Now, this is a key question that I want to talk about in the rest of the presentation. Which plants are likely to be medicinal? Which plants are likely to be medicinal? And like I said earlier, without theories and hypotheses, it becomes extremely difficult to respond, to answer this question. One of the hypotheses that can be formulated to respond to this question is called resource availability hypothesis. And you have ecological apparency hypothesis. These hypotheses are borrowed from ecology. They are not original ethnobotanical hypotheses. They are borrowed from another discipline. And we show, this part of the paper that I mentioned, I show in the last slide, we propose how the theory, the hypothesis can actually be formulated, what are the different variables that can be collected, and we show how we can test, we can collect those information and test the hypothesis. Now, the resource availability hypothesis, what does that say? If you are a plant growing in a poor soil, a nutrient poor soil, a soil that is poor in nutrients, those plants on those type of soil, they grow very, very slowly. They are slow growing plants because nutrients are limiting factor. Because nutrients are limiting factor, now it becomes expensive for them to synthesize tissue, to fabricate tissue. In that case, they have to develop a mechanism to defend heavily, something that is very dear to you. You define a strategy to defend heavily that thing. That's the basis of the theory. So because they don't have enough resources to keep synthesizing and fabricating tissue, the few that they have to develop a strategy to defend, to protect their tissue from herbivore attacks. Now, in that case, they use the most efficient defense mechanism that plants use, the chemical defense, right? So they synthesize some chemicals that chase away herbivores, that render their leaves unpalatable for herbivore, for example. In doing so, in synthesizing chemicals to protect themselves, they become medicinal for us. Because we are after the chemicals that they have synthesized to protect themselves against herbivores, and we humans, so they succeed somehow to protect themselves against herbivores, but they become useful for us, for humans. That's what the resource availability hypothesis predicts, right? That if you go at the plant, if you go in a nutrient-poor soil, you will more likely develop the chemical defenses, and thus far you will become medicinal for humans. The opposite is also true. If you go in a nutrient-rich soil, now you grow fast, the resources are not a limiting factor. You go fast. If a herbivore comes and harvests your leaf or any organ, you have the resources necessary to replace the leaf, the organ that has been harvested. Now, in that case, chemical defense is not necessary for those type of plants, but what we call quantitative defense, like